I'm Anil Kumar. Welcome to my series on trigonometry. We will look into related and correlated angles in this particular video. Here are 4 examples which will help us to understand the concepts better. You can always pause the video, try them out, and then look into my suggestions. So let's begin with the very first one. Question number 1 is: express as a function of its related acute angle and then evaluate. Now, what do we really understand by this statement? So we are given these trigonometric functions. We have to express them as in the form of their related acute angle. So first thing, let's try to understand what is related acute angle. So we'll take cos 4 pi by 3 as an example, and then look into related acute angle. Now when I say cos 4 pi by 3, it really means that this particular pi is divided into 3 portions, right? So let's say this is 1, this is 2, that is 3, right? And then we have 4, 5, and 6, right? When we say cos 4 pi by 3, it really means we are talking about the principal angle being at 1 pi by 3, 2 pi by 3, 3, and then 4 in quadrant 3, right? So that is 4 pi by 3. Clear? Now, when we are saying related acute angle, then we want to write the value of this in terms of this angle alpha. That is the related acute angle, always between 0 to 90 degrees. Or you can say we're talking about this angle alpha, right? Vertically opposite angles, they're exactly same. So this is what is our related acute angle. We want exactly the same value, but we want to replace the angle by alpha. Clearly from the sketch you can see that alpha is basically, this is pi by 3, right? So alpha equals to pi by 3. So it's so simple. So while working in radians, if you sketch or if you view the question, it becomes straightforward. Now another thing which is very important to understand is the sign. What should be the sign? Positive or negative? Now remember that in quadrant 1, all are positive, right? Here, only sine is positive. Here, tan is positive. And in this case, cosine is positive. Now, since we are talking about cos, and we are in quadrant 3, it has to be negative value, right? So we get negative, simply because principal angle lands in quadrant 3. Perfect. So we have a negative value. We are relating to acute angle, which will always be positive, but we want a negative answer, right? So now with pi, we can see that acute angle is alpha, and therefore it should be equal to cos of the acute angle pi by 3. Does it make sense? So we get our result. So cos 4 pi by 3 should be equal to minus cos pi by 3, since pi by 3 is our acute angle. So we have done the first part. That is to express the function of its related acute angle, then evaluate. Now let's do the second part, and that is to evaluate. To evaluate, we will always look into special triangles, right? So let me sketch the special triangle for the given scenario. So in this case, we have cos of pi by 3, which means the triangle, that is the angle pi by 3, right? This side is 1, this is 2, that is square root of 3. So you should know your special triangles. You should know this rule, in which quadrant what is positive. Then you can easily solve all these questions. So let's write down the answer. Cos of pi by 3 is 1 over 2, negative 1 over 2. So we get this value as negative half. Is that clear? So we get our answer as negative half. So that is how we are going to solve it. Is that clear? Now let's again use the same concept and solve tan 11 pi by 6. Okay. So I'm sure by the end of this video, you will definitely understand how to work with related and correlated angles. Now again, we are looking into 11 pi by 6. So in all, this has to be divided into pi by 6. So we have 12 pi by 6 to end with, correct? So 11 pi by 6 means we'll be somewhere there, right? So now we know that this much, going from here to this place, is 11 pi by 6, correct? What is the acute angle? Well, the acute angle for us is pi by 6, the angle which the principal arm makes with the horizontal x-axis, correct? So now basically, you are looking into this triangle, right, where the acute angle alpha is pi by 6, correct? You're talking about tan. As you can clearly see that tan is negative, right? Since tan is negative in quadrant 4, right, we have to write negative here, tan of the acute angle, which is pi by 6. So we get the first part. The second part here is to write down the value. So negative, of course, and we can use the same triangle, that is pi by 6, correct? Tan is the ratio of opposite over adjacent. So you get 1 over square root 3 as your answer, correct? Sometimes we may even rationalize this and write this as square root 3 over 3. The important thing is it has to be negative. Is that clear to you, right? So that is how it should be solved. Now let's take the last one, which is sine of minus 3 pi by 4. Now when we say minus, it really means that we are moving in clockwise direction, right? Now 3 pi by 4 means what? Well, let's divide this into pi by 4s, right? So pi by 4s are these. These are pi by 4s, correct? So when I say 3 pi by 4, 1, 2, and this becomes 3 pi by 4. Is that clear to you? So that is 3 pi by 4, right? Now once you do come to this quadrant, you are in quadrant 3. We know sine should be negative, right? So we get negative result, right? Now, what is the acute angle? Acute angle is this angle, which the principal arm makes with the horizontal. So 1 pi by 4 is left, right? So this angle basically is pi by 4, correct? So it should be sine pi by 4, right? So we get minus sine pi by 4 as our result. Now to get that, you have to draw the special triangle which relates pi by 4, correct? So for pi by 4, you know the sides are in the same ratio 1, 1, and this is square root of 2. So for pi by 4, you get a value which is negative 1 over square root 2, which you can also rationalize and write as negative 2 square root 2 over 2, right? So that is the result. So I hope it is absolutely clear, right? Now, once this concept is clear, let me give you 2 questions to work with. So you can do sine of, let's say, 7 pi by 6, and then you can also try, let me write here E, let us say cos of minus 6 pi by 4. Okay, so I'd like you to try these questions on the same concept. So I hope all the steps are absolutely clear. Let's move forward and do question number 2. Here is question number 2. Express as correlated acute angle and then evaluate. So part A is sine of 5 pi by 6, B is tan 25 pi by 6, and C is cos minus 7 pi by 4. We need to understand few terms here. One of them is correlated, the other one is the acute angle. Do you remember the special triangles? So that forms the base for us, right? Think about this. Let me make one special triangle for pi by 3, pi by 6, right? Okay. So let's say we have this triangle and this angle here is pi by 3. Then the other angle is pi by 6, correct? Their sum has to be pi by 2, correct? Okay. Now, let me write down this value as 1, this is 2, this is square root of 3. When we say correlated, we want to write sine function as cosine function. This is first step. And when we say acute angle, we want one of these smaller angles, right? Which are less than 90 degrees. How do we do it? So, let's figure this out. When we say sine of 5 pi by 6, we really mean that the principal angle is here, right? So we are in quadrant 2. In quadrant 2, sine is positive. We know all are positive here. Sine is positive in quadrant 2, tan in 3, cosine in 4. So we have a positive value. So we should get positive value. Correct? The other thing is, what is the acute angle? Well, this angle, which is alpha for us, which we found in example 1, is basically pi by 6. So that is your alpha, correct, in this case. So pi by 6 is this angle for you. When we say correlated, we are looking into the other angle, correct? So the other angle is pi by 3. So we get this as cos of pi by 3. Does it make sense to you? So that is how we get correlated acute angle. So these are two correlated angles. How do we get correlated angles? You get them by taking away the angle from pi by 2. Right? So when you do pi by 2 minus pi by 6, you get 6 common denominator, 3 pi minus pi, which is 2 pi by 6 or pi by 3. That's what we got. Correct? Now, as far as the value is concerned, cos of pi by 3, if you look from here, is half. You will notice that sine of pi by 6 is also half, right? Which is of course equal to sine of pi by 6 also. So it works. So I hope you got the concept, right? Let's do it once again for tan 25 pi by 6. Now when we say tan 25 pi by 6, means this is 12, right? This is 12. 12 pi by 6 is 2 pi. We go one more circle, we made it 24, and 25 is right there. Correct? So you land up in quadrant 1, so it is positive. So the result is going to be positive. Coterminal means we have to write in terms of cotangent. The only thing is we need to now find the acute angle. The acute angle in this case is pi by 6, right? So alpha here is pi by 6. So again the same triangle. So the related acute angle will be pi by 3. You get the idea? And cot of pi by 3 is what? You're looking from this side, 1 over square root 3. So that's what it is. So first you write them in terms of correlated angles and then you evaluate. So we've done both the things. Is that clear to you? Let's look into the last question now, which is cos of minus 7 pi by 4. So when we say minus, we have to move in clockwise direction. Total is 8, 1 less than 8 is 7. So we'll land up here. This is minus 7 pi by 4. The acute angle is pi by 4, correct? And pi by 2 minus pi by 4 is actually pi by 4. So we could write cos as its correlated angle as sine, correct? And the angle is pi by 4. Since you are in quadrant 1, all are positive, so it has to be positive, correct? And the value is 1 over square root 2. Is that clear to you? So that is how we are going to figure it out. So I hope the steps are absolutely clear, correct? Now practice question for you, D. You can find for sine 5 pi by 3, right? And let's add one more, tan of minus 3 pi by 4, okay? So those could be your practice questions. Now let's take a short break and then get back to question number 3. I hope that helps. I hope you enjoyed the beauty of nature. Cormorant is excellent fishing bird. You saw how quickly it engulfed the fish and took a beautiful flight. I was lucky enough to capture it. So let's continue with question number 3, which is simplify each of the following. Now in these examples, you will notice that I've written x minus pi by 2 minus x minus pi, correct? Now, we need to understand one more concept before we get into this portion, and that is to say that we should understand what is sine of minus theta equals to, what is cos of minus theta equals to, and what is tan of minus theta equals to. Well, sine function, as you know, is an odd function, right? So it's kind of like this. It's an odd function. Do you see that? So this is like minus sine theta. Similarly, tan is also an odd function, so it is minus tan theta. However, cosine is even function, right? As far as the cos is concerned, it is kind of like this. Do you see that? It's like this. It's an even function, right? So this is equals to cos of theta. That is one way of figuring it out. The other way is, all are positive here. Cos is positive here. Sine and tan are in positive on the left side. When you say minus theta, then basically you are relating these two, right? These two. So for minus theta, cos is positive, so it is positive. Does make sense to you? So either way, you could think about it. But remember, sine of minus theta and tan of minus theta are negative values, and cos of minus theta is a positive value, since that lands up in quadrant 4, right? Okay, so that's kind of important. So when we have to simplify each expression of these kinds, our first step is going to be to rewrite this in terms of pi first, right? It helps. So we could write this as sine of, and let's take minus common. So we are left with pi minus x. Does make sense to you? Here also we'll do tan of. We'll take minus common, right? And then what we get is pi by 2 minus x. And in this case, we have cos minus common. We get pi plus x. So that is our first step. So we wrote it in the standard form like we are used to, right? Now, the second step will be apply this identity, right? Cos of minus theta is minus cos theta. So I should be writing this as minus of sine pi minus x. This one will be minus of tan pi by 2 minus x. And this will be positive cos pi plus x. Is that clear to you? So these are your first two steps for such trigonometric functions. Now you know what you have to do. Wherever it is pi, in that case we have a co-function. We have the same function, right? So they are kind of related. So whenever it is pi, they are the same functions. So pi minus x means what? Look at it like this. Let's look into these terminal arms so that we get an idea whether we should get a positive value or a negative value. So when I'm saying it is pi minus x, That means less than pi, right? So we are somewhere here. We know this portion here is positive, right? This portion is positive. So, but there is a negative sign there. That remains as negative, but this whole could be written as sine of x. So we get that as the simplified form, right? Pi by 2 and pi by 2 minus x means you are still in quadrant 1. So in quadrant 1, this portion is positive. So what we get here is minus, tan becomes cotangent, right? So it is cot of x, right? Pi by 2, wherever it comes, you get the cofunction, right? It's the other side of the triangle, okay? Now the last one here is pi plus x. Now pi plus x means you are in quadrant 3 where cos is negative. Since cos is negative, we write negative here. Since it is pi plus or minus, it becomes cos of x. So that becomes your equivalent expression. Perfect. So do you see how these 3 steps help us to get the right answer? Perfect. Now here are your practice questions. Let me write down D, E, and F for you to practice, right? So let's write cos of minus pi plus x, sine of minus pi by 2 minus x, and then we'll write tan of x minus pi by, let me write plus pi by 2, right? So those are your practice questions. I'd like you to solve these now. Perfect. Now let's take up the last question. Here is question number 4. Now I will like you to pause the video, answer this, and then look into my suggestions, correct? So let's begin one by one. We have cos of pi plus x. That should be equal to what? Well, cos pi plus x means you are in quadrant 3 where it has to be negative, and therefore it should be negative of cos x. Is that clear to you? So when you're writing a simplified version for this, I will replace cos pi by x with what? Minus cos x. Is that clear to you, right? So that is how we'll do one by one. So the first term here will be minus cos of x. Now let's look into the second part, which is cos of pi by 2 plus x, right? So when I say pi by 2 plus x, we are here. Now that is a cofunction, right? So we get sine of x, but since you are in quadrant 2 where cos is negative, we expect a negative value. So this becomes minus sine x. Is that clear to you? Perfect. Now let's look into cos of pi minus x. So when it is cos of pi minus x, you are actually here. Now again, cos is negative here, so it is, oh sorry, this is cosecant, right? Cosecant is, this is not cos, this is cosecant. Pi minus x. Now cosecant is reciprocal of sine, right? This is reciprocal of sine, and you are in quadrant 2, it will remain as positive, so it becomes cosecant x. Now let's look into the next term, which is cos pi minus x. Okay, so as far as the cos pi minus x is concerned, cos of pi minus x means you are again here, right? Pi minus x, that is the position. Cos is negative here, so we'll write negative cos of x. Clear? Now the other two. We have sine 3 pi by 2 minus x. So when you say sine 3 pi by 2 minus x, that means you are here, right? 3 pi by 2 less than that in quadrant 3. Sine will be negative. So we'll write this as negative of cos of x. 3 pi by 2 or pi by 2 plus minus will change it to cofunction, right? So that is how it should be. Now the last one here is secant of pi plus x. So secant of pi plus x means you're here. Secant is reciprocal of cosine, so this will be again negative, and it will be negative secant x. Is that clear to you, right? So that is how we will get all the equivalent expressions. Perfect. Now let us simplify and write down our answer. So can you cancel few terms? Well, we can cancel minus cos x with minus cos x. So cosecant is 1 over sine, this is negative sine here, so we get negative sine x times cosecant is 1 over sine x, right? So we get this. Here we have minus these two negatives. Will cancel, this minus remains. We have minus cos x, and secant is 1 over cos x, correct? So what we get here is minus sine square x, and this is minus cos square x. Well, you could take minus common, so if you take minus common, you get sine square x plus cos square x. And you know this is 1, so we get minus 1 as our answer. So our answer in this case is negative 1. Is that clear to you? That is how we are going to solve it. So I hope all the steps are absolutely clear. So we have kind of revised what we have just learned in this video. I hope it is straightforward. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.